So thank you everyone, and thank you for the invitation. So I'm Stefan, and I'm here to introduce you to the Tendiboots technology and explain to you what is it and how it can be useful for your practice. And if feel free to stop me if you have any question in English. It's better. So I can see the chat and we can have an exchange. So it's sometimes it's a little bit more entertaining to have a discussion. So I will just explain a little bit who I am, what is Ekico, to give you context. I don't know if you know them, if you know us or not. So I'm Stéphane Juban. I'm one of the co-founder of Ekico. I'm the technical guy inside the company, and I'm a computer science engineer. And I've been supporting practitioner for the last 9 years, almost 10 years now, whether it is for equine or canine, more recently. But even before that, I was also in the data and the interpretation of data, but it was completely different. It was for motorcycle, but anyway, it's numbers that we need to interpret. So it is kind of the same for me, at least. So I turn data into actionable insight. And about Ekico, so it's a French company. If you didn't recognize my accent, and first, so it was founded in 2016, so almost 10 years now. And first, it was for equine mainly only. This is why we are called Ekico. So it's a contraction of equine and connected. So this is why the name. And today we are a team of approximately 8 people, more or less. But we are obviously engineers, but also biomechanists in equine or canine, data scientists, obviously developer for all the mobile application, the website, etc., and a marketing specialist. And we are proud to have more than 300 professionals across all the world. So here it's 30 countries, but it's now at 31 even. And they are very spread from New Zealand to Hawaii, and we give and we offer the same support to anyone, whether you're anywhere in the world. So this is something that is really important for us. That when you purchase a device from us, you are supported, and you can contact us anytime, and we can help you from anywhere. And now we have more than 40,000 analyses of gait that we have recorded and turned into actionable insight for our users. So we start to understand pretty well how dogs and equine works. And yes, so as I told you before, so this is how to give you a little bit of context of how the technology is adopted across the world. So mainly in Europe, obviously, and in the US, but not only. So we are here to talk about the Tendiboots technology. So I don't know if you have heard of it yet or no. But as I say, it's both for equine and canine. You will have it's almost the same. So for today, I will focus my presentation more on canine, but I would say 80% of both equine and canine are the same. There is only slight change for equine. But basically, it is sensors that you place on the limb. So the sensor is a condensed set of technology. So you have I don't want to be too much technical because this is not the main thing here, but you have accelerometer, gyroscope, magnetometer, and all of that is compute in real time inside the sensor, and we collect all of that thanks to a very user-friendly mobile application. So the connection is via Bluetooth, but you can have a wide range of motion. So you are not forced to be very close to the animal to get a signal. And we have designed it to be very useful in a very large wide of breed. So, for example, you can go up to more than 70 kilograms. But we have recently adapted our system for tiny dogs. So for us, tiny dogs will be under 7 kilograms. So here, for example, this dog on the left who is a 4 or 5 kilograms. And what is good is that you don't need to buy another system. It's just the sensor is the same, and we have just adapt the holder, what we call the holder, which is this. I don't know if you see it, where you place the sensor inside. So very easy for a very wide range of dog. And how to use it, there is 3 very simple steps to use the system. So first of all, you put the sensor holder on the dog in just a few seconds. So usually this is the owner who does it, and he is quite happy to be involved and part of the process. So this is what we get as a feedback. And then you let the dog move freely, so it gets used to the system. At first, the dog will dance a little bit, but it's normal. It's part of the process. And in 30 seconds, 1 minute, usually, the dog is used to it, and he returns back to his normal gait pattern. And at this moment, you are ready to put the sensor inside the holder. And after that, you connect to the sensor via Bluetooth, and you let the dog walk for 10 seconds. So every recording is 10 seconds long. So you start, and it automatically stops after 10 seconds. And we recommend doing that at least 4 times. So it's a back and forth 2 times. And so we get enough data. So usually we get 10 strides in 10 seconds, more or less. So, but if the dog moves a little bit on the left or on the right, so it's better to repeat. So we have enough data, enough quality data, I mean. And after that, you get the result of the gait in just a few seconds. So it's very, very quick. And about the data, this is what we will show to you. This is not the only data that we have, but this is the one that we choose to display because this is the more useful data, if you want to say like this. So we have the number of strides. So basically is to give you an idea of how much stride we have analyzed. It's a kind of quality measurement. And you will have also the velocity, the angular velocity. So it will be how fast is the leg when it is in the air, how fast is it going forward. And we have the stride height and length. So it will be more about articulation, the mobility of the articulation, if you want to understand how it is calculated. We have the peak vertical ground reaction force. So it is how fast, how hard the limb is impacting the ground. So basically, the more you have data for this parameter, the more comfortable is the dog. It's not always the case, but I'm simplifying the interpretation here. And after that, you have the duration, so the stride duration, basic information, and how much time the paw is on the ground. So to give you context, if he's putting weight a long period of time or a shorter period of time. So this is the data that you get, and we always compare left and right. So to give you a percentage of how much is on the left, how much is on the right, and so this is what we see here. For example, you will see that some data will turn bold or more dark, and in this case, that means that it is unusual because we, as I said in the beginning, we have multiple thousand of recording of dogs or horses, but of dogs healthy. So we know by statistics how should be a balance between left and right for an healthy dog, and if we fall outside of this range, we will give it this information to you, so you can do something with it, or you say no, it's okay. I understand why this parameter is outside. I know this dog and it's usual. Or you can say, okay, this is not normal. For example, here the peak ground reaction force, we saw that we have 22 on the left, 14 on the right. There is a real imbalance, and when you click on it, you will have a little more details if you want. That will tell you usually we have a 2% difference, and now you have 40% difference. So maybe take a look at this parameter and try to work to balance back this information, this data. We have also optional add-on features, such as the bar chart, so the symmetry result. It is more or less the same information as we saw previously, so with the numbers, but this time more easily interpretable. So you can clearly see, am I in the green zone or am I outside of it? So this dog, for example, is clearly outside of the green zone. So the green zone is what we say a healthy dog, and if it's outside of this green zone, that means it is unusual for an healthy dog. So you can clearly see it, and it's more visual maybe than numbers. We have also history features, so you can see over time, over a long period of time or a short period of time, how the dog is evolving. So, for example, here this is a dog that was recorded during the season, sport session. Sorry, and we see that at the beginning it was so the 0 is a perfect symmetry, so the dog is perfect, really balanced, and he started the session perfectly balanced, and he was doing a training session, and after the training session we recorded back the dog, and we did this training session, and we repeat this process, and we see that at the end of the training session, so more or less 1 hour after the first recording, we saw that there was a clear imbalance on the left that was being created. And when the vet checked this dog, there was an issue. So it was a clear early detection of something wrong. So they were able to treat this dog very early. So it was very, very useful in this case. And finally, we have also the PDF generation report, because this is something that a lot of people request to share easily with owner, or to put it in their own software or whatever. And to finish with theory, I would say. We have also a lot of some presentation that we did or some validation studies. We also encourage our user to share their use case, whether it's on our blog, so you can see it on our website if you want, but also during veterinary congress. So it's always useful for us, for them, and for everyone else to understand how real user or real vets or physio or whatever use it in their context. And we have also published 2 posters, and we have 2 more to publish, one in September for a congress, for the World Congress of Veterinary Congress, I mean, and one in October for the European Congress of Veterinary Surgeons. The first one here on the left, bottom left, was how we use artificial intelligence to detect which limb was lame. So always, as I said before, since we know how a healthy dog is, and we also know some lame dog, we were also able to detect or to predict with 80% accuracy which limb was lame or not on any new dog that we record. So this was the first poster that we presented, and one other was to the evaluation of different induced lameness. So we induced lameness at different grade, and we checked how the system was responding to this grade, and we compared it with assessment from vet, and it was very well correlated. So yeah. And to go a little bit more less theoric, and I wanted to share with you some real tests that we did. So for that, we have conducted with one of our users, which is chiropractor. We have tested on 3 dogs before and after recording, before and after manipulation, I mean. And so it was interesting to show you how the dog was evolving and how the data correlated or not with the dog. So for that, we use 3 dogs of approximately the same weight, so 20 kilogram, and they were clinically sound even before, and so no lameness or disease or pain. And when we say lameness, we refer to visible unilateral head or pelvic hike, unilateral head nod, I mean. And there was a screen, so with a thermal camera, so there was no heat, no swelling, or no skin lesion. And they, as we recommend, they were always used to or acclimated to the system before doing a recording. So this is a 30-second period that I explained to you just before, and they were able to walk on lead with the owner. And yes, maybe I didn't say that before, but we recommend doing the recording on a straight line always. So this is how the analysis is trained to analyze. So for the manipulation is basic manipulation of the full body of the dog, and yeah, that's all. And so for the first dog, it was observed with a pelvic crabbing to the right, with a reduced stride length on the left. So this is a clinical observation of the practitioner here. And there was an asymmetry more pronounced when trotting, especially when he was excited. And so we see that, for example, on this dog, the stride length was greater on the right. We didn't pick up anything on the front here. There is no data or bold. But on the hind, we have two data, so the stride length and the impact. And if we, for example, if we put all the data on the table like this, we see that some like this, the 4 here, are not usual when we compare to the other pair. So the front pair are more or less the same as we saw previously, but the hind pair is unbalanced. So, for example, the stride length, we have 15, and here we have 23. So this is a huge difference. The peak force, it is small, but yet it is picked up by the system to be unusual, and same for other parameter. So the hind limb asymmetry with left hind is showing significantly reduced stride length, and etc. And the data aligns with the clinical observation of the practitioner. And this is an average of all the 60 stride, for example. So it is more or less 2 back and forth. So it is important. It is not only one recording that can have a bad stride. And after the manipulation, so the clinician observed an improvement. The stride lengths were visually reduced, and the dog remained exciting during trot. Yeah, but yet we directly see that there was an improvement in the data, because there is no more highlight that is showing. The symmetry is much more better. And if we go back to our table, so now it's 80, almost 90 stride. So it is a good amount of stride to have a proper analysis. And we see that when we compare left hind and right hind, now the data are much more symmetric and much more usual when we compare left and right. So we in this case, we clearly see an improvement of the dog visually and with the data. And if we check the symmetry result that we see earlier, we see that here we are at the entrance of the red zone for both the stride length and the peak ground reaction force. Other than that, we are normal for a dog. And after the manipulation, we see that all parameters are on the green area. So that means this dog is considered as healthy based on the data that we have, as always. The second dog that I wanted to share with you is same dog that presented crabbing to the left at work and worse in trot, and also a reduced stride length. And after the manipulation, always as before, it was much better and increased straightness through trunk and hind limbs. So in this case, it is a noticeable before and after improvement of the dog, and subjectively observed, because it is only subjective when you check with your eyes. You can be very trained and very skilled, but yet it is only your observation, and sometimes the owner cannot see the difference before after, so he cannot rely only on your experience. So this is why data and objective data that we can offer is always good for example, the owners. And here, when we compare the before, so over 100 stride, we saw that there was some parameter also in the red zone, and so after everything is back to the green, but the stride height is barely at the limit. So this is something that improved, but you can maybe improve a little bit more. So in this case, for example, you would, if you see the dog maybe one week later or 1 month later, this is something that you will remember. And when you check back the data, how was this dog last time I saw it? Okay, we improved this parameter, but it's not yet perfect. And so you can focus on this parameter. So from subjective impression to measurable change, there was a clear improvement after the treatment of the dog. And the last example is something completely different, because this time the dog before manipulation was good. There was nothing special. Good range of motion, same stride length, nothing. And after the manipulation, it was the same. So the clinician did not see any specifically change. And so we in this case we can compare how the system work and what information it gives you before and after. In this case, that you did not see anything different. So if we check the data in this case, before you have a green zone, even if the peak ground reaction force, for example, was barely at the limit on the hind here, as you can see, and when you check back the after, it is still on the green. So as you would say subjectively, everything is on the green. So this shows that even with an LC baseline, there is a consistency when you check before after, that the dog is on the green zone, and there is no dysfunction, no change, or just stability for those dogs. And if we want to go a little bit deeper, this is the same dog before and after, and we can see that even if there was no significantly change, or it was LC before after, we see that there is a little bit of improvement after. So if you want to be a little bit picky and go deeper in the data, because here there was approximately I don't know, maybe a 10% difference more on the right, and here we are almost at 0, so the baseline, so better symmetry overall, even if that's okay before and after. So there is just 3 key takeaways to share with you for this 3 case studies that are a little bit different. But the first one is that can help detect subtle dysfunction that matter, and that you can translate your subjectivity into objectivity, and maybe that can help you quantify things that you might miss, because, for example, you will focus on the head, and you will not see the stride length, for example. So it will give you objectivity across all the parameters of the gait. You can clearly track and visualize change over time. So how it was before, how it is now. Is it better? Is it worse? And how much better? Because it is easy as a way of saying that, but it's easy to see that there is improvement. But how much better is it, and what is better, etc. All of that is more easy to explain and to see with objective measurement. And it's also provide a consistent and repeatable data that you can trust. And this is how we saw with the last case study with the dog LC before and after. And so yes, to finish, there is a sentence that is important to us, is that Tendiboots doesn't replace your hands or your eyes or your experience. It just enhances them and to give you more information. It's a decision support tool designed to straighten your diagnosis, guide treatment, and communicate progress more clearly. So that's all for me. I hope you discover and you learn something, at least about the device. So if you have any question, feel free to ask me, and I will be happy to answer them. If you want to follow us or to know more about our device, how other people use it, we have a blog on our website, so ekico.fr, when there is a lot of use case sharing. So it is always good to understand in which context people use it, how they use it, what they find useful, etc., etc. So there is a lot of information also on our website that you can check when you want.